So ladies and gentlemen, we are finally at the most awaited session of the entire conference. Most awaited for two reasons. The fact, the promise of the word that it's the last one also means that after this we are all free to just relax for a while till we meet at the beachside lawns, at the seaside lawns for a beautiful Goan themed evening. But since we are in Goa, and right now the entire India is celebrating the biggest festival which comes every 5 years, the festival of democracy, the national elections. It also means that the model code of conduct is in force, which means that the music must shut down in time. But worry not, you're in Goa, we have ways around that as well. So the party continues in the Mobor Hall after 10:30 onwards. Ladies and gentlemen, there's something that I've been noticing since yesterday when I kick-started the conference for you all, that at least while silver as a commodity, as a metal, as a material is very, very diverse, what I realized was that as a sector, this sector lacks diversity. I mean, as I see all of you men sitting here with rarely spotting a sister here or there, I do realize that this is a male-driven industry. So while you've all gone out, which I'm sure you have, you've gone to the expo, you've checked out the stalls, I urge you to please stop by at the Annie D discounter booth, that is Annie Dimension. It's a very young startup by two IIT graduates, IIT Mumbai ladies. It's an all-woman startup. Please give them your support and at least give them some eyeballs. I'm sure they'll appreciate that. With this, as I start inviting our next speakers, another reason why this has been the most awaited session of the entire conference is because apart from the fact that we get to hear the research institutions, the end of this session will be punctuated by a freewheeling roundtable between industry and research institutions. That is where the real talks come, and that is where the key takeaways will happen regarding the technologies and applications of silver for future. In order to moderate this session, I would like to invite the President Works for MMTC PAMP India Private Limited, Mr. Ankur Goyal. Let's give him a round of applause as he joins us up here. Joining us on the stage is a team of three very, very well-known, very, very accomplished and highly respected academicians, starting with Professor Parag Bhargava, who is a distinguished figure in the field of materials engineering, particularly renowned for his pioneering work in ceramics and surface coatings. With a prolific research portfolio spanning over 2 decades, he has significantly advanced the understanding of various aspects of material dispersion, UV curing behavior, and bonding strength in ceramics, and his expertise extends beyond the laboratory, as evidenced by his co-funding of Ant Ceramics Private Limited and his numerous accolades, including the prestigious Commercialization of Indigenous Technology Award presented by the President of India himself to Professor Bhargava. Let's give a huge round of applause as Professor Bhargava joins us up here on the stage. Our next distinguished guest this evening on the stage will be Dr. Ashok Kumar Mohanty. Serving as the principal scientist, he stands as a leading expert in material science with a focus on innovative solutions for industrial challenges. With a PhD as his educational cornerstone, Dr. Mohanty's expertise spans diverse domains from self-healing polymeric coatings to the replacement of industrial toxic elements. His prolific research output, highlighted by 24 published papers, reflects his dedication to advancing knowledge and practical applications as well. His comprehensive expertise and publication record positions him as a key figure in the field, driving innovation and progress in material science and engineering. A big round of applause to Dr. Ashok Kumar Mohanty. And finally, now Dr. Ashok Kumar Mohanty is the Senior Principal Scientist for CSIR-National Metallurgical Laboratory. I would also like to tell you that Professor Parag Bhargava is a Metallurgical Engineering and Material Science, is from Metallurgical Engineering and Material Science Department, IIT Bombay. Our final speaker this afternoon for this session is the Senior Principal Scientist and Professor, Chemical Engineering and Process Development Division, CSIR-National Chemical Laboratory, Dr. Amol Kulkarni. Dr. Kulkarni is a distinguished scientist at the CSIR-National Chemical Laboratory, Pune, bringing extensive expertise and innovation to the realm of chemical engineering and process development, with a solid foundation in chemical engineering from the Institute of Chemical Technology, ICT, Mumbai, where he earned both his bachelor's and doctoral degrees. He has since embarked on a remarkable journey of research and explorations. His postdoctoral stints at MPI Magdeburg, Germany, Massachusetts Institute of Technology, USA, further enriched his expertise and perspective, and at NCL, he leads pioneering research in the design and development of microreactors, paving the way for continuous synthesis of pharma intermediates, dyes, perfumery chemicals, and nanomaterials. Ladies and gentlemen, as I leave this session in the hands of Mr. Ankur Goyal, I would urge all of you, please be with us right till the very end, because after this, once we close the formal presentations, we shall dive directly into an informal roundtable between industry and institutions. All yours, sir.
Yeah, good afternoon, everybody. I think this session would be a very interesting one. We have three people, all distinguished professors, and I've been talking to some of them. I couldn't talk to Professor Parag, but a lot of work has been done in their laboratories in terms of the research in the silver field. And I think without taking much time, we can start with the presentation in the order for Professor Bhargava can start with his presentation. Thank you.
Hi, am I audible? I think so, yeah, it does. All right, so it's a pleasure to be here for the second India Silver Conference, and thank you, Mr. Srivatsava and your entire team for this opportunity. I think hopefully, you will find some answers to at least the questions which were being discussed here about, why not silver powders and pastes in the country. So I have some of those answers, but I just chose this title. I think it fits well, right, from whatever has been going on. It's all over. Think of any application. Probably we should have a challenge. Which application does not really use silver, right? So silver, the omnipresent. And I will take you through some of the things that we have done in the lab, reminding you a little bit from the last time and what new has been added. These are things, so we have been synthesizing, as I said, the question whether we can make powders in the country or not. So we've been making powders for quite some time now. We've been evolving over the years, but we can control size, shape, morphology. You tell us what you want and we will give it to you, okay? So we are able to do that, right? Now, just a few slides. I won't repeat what has already been discussed, tonnages, how many tons per gigawatt and all that. But silver pays for solar PV. You have seen some numbers almost in those ranges between 15 to 20 tons per gigawatt. All of that, the need is there, right? Just pictorially, things that we have been doing in our lab for the silver paste. We can start from silver powder on our own, whatever morphology size needed. Some of the pastes, like Shivani said and others said, that for high temperature paste, right? For example, for Perk and Topcon, you need to add a glass, so we make our own glass. And then we formulate these pastes, do the mixing and all of that, and entire testing. I won't bore you with the details, including, rheology, printability, and everything else, adhesion, all kinds of things that are needed, we are able to do it in our lab, right? This is a cell printed in IIT Bombay, and for those of you who are not aware, IIT Bombay is the only place where MNRE has funded a center called National Center for Photovoltaic Research and Education. We have a pilot plant in IIT Bombay, so anytime you bring up new materials, new technologies, we can pilot them at IIT Bombay. We have a good number of professors, faculty members who cover almost all technology of solar PV, right? Whatever you are going to come across. So this cell was produced at IIT Bombay. You can see the bus bar, the fingers, current collection fingers, which you just heard, and a representative IV plot, about 15% efficiency. Of course, this is not done at an industrial scale. We are now at a point where we are ready to do a pilot with the industry. Of course, if there are interested people, we can talk about that, how to go further with this. Now, another interesting development, as already, it has been referred to by Chandresh and maybe others, that, the other interesting aspect from the solar PV around the world, there has been an interest in both for high temperature paste and particularly low temperature paste for HJT, that can we have silver coated copper. So we said, okay, there's a lot of interest, why not just end at silver? So we did some copper powders. These powders have been done in our lab. You can see the scale bar there, 1 micron, right? The next slide shows you silver coated copper powder. So this is something which is very useful for these low temperature paste as well as possibly for high temperature paste. So we are moving in that direction, and this is some recent work. You can see, I mean, if you just focus on the right picture, let's see if this thing works. Yeah, this one. So I'm talking of this picture. If you see this picture, this is taken to show that this green color tells you that the copper powder is entirely covered by silver. So that way you can actually lower the cost of the powders that you put in, right? And you can use it for low temperature paste without any trouble. It's the high temperature where there's a problem. So now we also do silver paste for printed electronics. And you will see, there are things I have also pointed out earlier. For example, we are able to print these pastes on flexible substrates. This is a printed heater with silver and carbon. The silver paste was produced in our lab. This is a trial done at an Indian industry in Mumbai for, again, membrane keypads, which was being referred to in some of the earlier presentations. And then this is some interesting thing. I won't go into details, but we have been approached by defense labs where they want to look at some stealth applications. This is something new for us also, but in stealth applications also they need precious metals, where they can actually print certain patterns and build in stealth in the defense and aerospace kind of industry. This is something well known, so I won't go into it. Use of silver nanopowders, particularly in this case for antimicrobial applications. And then we have silver inks, and this is something to do with, it was already mentioned that our student and one of my postdocs, they have a stall here, and we just started a company based on these silver inks. And some of you would have seen, hopefully, that we now can make, these pens which have silver ink. So it's, you can basically, once you have a silver ink, you can draw conducting patterns on anything. You can write on paper, you can write on plastic, flexible substrates, and essentially maybe do paper electronics, so to say, right? This is not the conventional application that we have been talking about. It's more of educational use, but interestingly, you will see it doesn't end at education. That's what we are also excited now. We are only, as a company, we are only 2 months old in a way, right? So we are discovering many more things. This particular thing that you see here is actually being used by a startup in ISC Bangalore for PCB, prototyping, okay? And this is what was exciting to me. So there is a company which is using our pen and silver inks for actually repairing keyboards. I remember myself having thrown away keyboards which stopped working, certain keys don't work. So this company is there which can actually repair keyboards using material that we are making, So this basically is very nice from the environment standpoint, right? So you can actually recycle your keyboards. This is something very exciting, done just recently. I can't show videos, I had the videos, but this is basically, this one is a XY plotter, and the pen is being held by the XY plotter, so you can actually plot any kind of pattern. So you can have literally like a robotic arm or a XY plotter, and you can like write patterns using this particular pen. Okay, and these are different pictures with whatever we have been doing related to these silver inks. And this is the, like the kit, this is the booklet in the kit, I said electricity on paper. So this is more of educational, basically to teach children some very exciting and very basic concepts of electrical circuits, right? These are some list of experiments. And I just put up this thing which you also will see on the stall, that this is, all of us are really excited with this silver conducting ink pen. So if you get interested, please come by, or you can talk to us even later on about this. Of course, doesn't come in the domain of the industrial applications, but in general, as I said, very, very exciting that we can actually write conducting patterns. Lots of things about that. As I said, not only it's a unique experience, but you actually can have conducting patterns. Also, this is the entire kit which is shown, on the stall there. As I said, electricity on paper. These are things now. This slide kind of lists out things that we are able to do. We can do. We can give you inks, and by the way, I should just mention it. Even though it's a silver forum, we can make inks with most other functional materials. We can make inks with dielectric materials. We can make inks with carbon. We've already made. We can add those to the silver because that enables more applications. If you want to make sensors, you just can't make sensors with just silver ink, right? So you need all these other inks also, right? So we can do sensors, we can do printed electronics. As I said, we have shown some flexible heaters. Solar cell, of course, that's a very important area for us. Membrane keypads, and maybe you can add more things to this, right? So it'll be really exciting. If some of you have interest, please come and talk to us and see whether in which way we can work with you, right? And that's the last slide I have. So we'll be really happy if you are also interested in investing in growth of this startup, which will really encourage our student and postdoc. And of course, it's a business, right? So all those things can be discussed. That's all I had.
Thank you, Professor, for this wonderful presentation. I would request Mr. Mohanty to share his research activities.
Thank you, and good evening to all. So myself, Dr. Ashok Mohanty. So I am working as a senior principal scientist in CSIR-National Metallurgical Laboratory. So today I will be talking on a hot topic. I think there is a great deal of demand in the industry, how to protect silver from tarnishing. So it can be jewelry, it can be decorative items, a lot of things, including your contacts. So maintaining the luster and brightness of silver is a very important thing. And as I see the feedback from the users, industries, they are more dependent on foreign, that means imports. So our objective is to how to make it in India, and being from a CSIR, so let me introduce our institute. So it's on behalf of my next speaker. He is from also CSIR. So CSIR stands from Council of Scientific and Industrial Research. So the name itself tells that it is founded to help the industry, Indian industry. So we do the research to help Indian industry solve their problems. So unlike a IIT, which is more focused on publication, research, to teaching, CSIR is more focused on providing industrial solutions. So we invite all of you to visit. We have 37 laboratories across India having specific mandates. Like in our lab, it's metallurgical laboratory, metals, materials, and minerals. So starting from extraction of a metal to how to protect to end user, we cover the entire gamut. So we have around 200 scientists, and we cover all those things. So now coming back to the topic. So many of us, we tell in common terms, we call it oxidization of silver. When there is a tarnishing, we call silver oxidized. But if you more go to the scientific, it's not, it's oxidation is happening, but the blackness is mainly due to formation of silver sulfide, reaction of silver with sulfur containing gases like hydrogen sulfide, sulfur dioxide in the atmosphere, and they make the silver sulfide. So it's basically sulfidation. Oxidation is very less. Actually, oxidation layer will be few nanometer thickness, but major is the sulfidation, which gives the black color. Now this black color richness varies from, starts with light brown when the thickness is 10 to 30 nanometer. When the thickness increases to up to 100 nanometers, it becomes bluish brown. And when it becomes more than 100 nanometer thickness, it becomes black. So that is the how it looks tarnishing. And the simplest test is actually, it's called egg test. So you can also check your how tarnish resistant your articles are. Simply take an egg, boil it, and take a pouch, put your article and egg inside it, boiled egg, cut into pieces. So this boiled egg basically emits hydrogen sulfide. So how it is emitted, this white portion of the egg, it contains amino acids, sulfur containing amino acids. When you boil it, it emits the hydrogen sulfide gas. And that you can see over the period of time, within 30 minutes you can see the spoon has completely got tarnished. So this is the simplest test. If you don't have any equipment in your lab, you want to check the efficiency of your how tarnish resistant is your article. You just do this simple test. You can know, and you can compare. Suppose two anti-tarnish reagents you have, then depending on the efficiency, one will get tarnished in 30 minutes, one will get tarnished in 1 hour. So that means the more the time it takes, more the tarnish resistant it is. So this is the simplest test. Now that was the problem. Now we at NML have come up with a solution to clean and provide the tarnish resistance in a single step. And key point here is that a variety of solutions are available in the market, including international market. They claim a lot of things, but the thing happens that they almost all contain either acids, nitric acid, or contain a thiol compounds like thiourea or kind of things. So these are not safe compounds, safe chemicals. So our objective was to make it a safe green chemical suitable for all. So you should be able to make it in the household also without any knowledge of the chemical. So that we formulated using citrus chemicals, and we have taken the help of our Ayurveda. So our old traditional knowledge, we know mainly that tamarind as well as our lemon, all these are used for cleaning, and we have chosen that one, that active chemical contained in that's a carboxylic acids. So we extract that one, and then we make a formulation out of it, and it's completely safe and even edible. Suppose somebody drink it by mistake, that also there's nothing going to happen. That kind of safe chemical it is, and it produces a clean surface comparable to any product available in the market. So that can be also used in industrial scale, like in the final step of your industrial production, you use either a vibratory polishing machine or use a ultrasonic machine. So you simply use this chemical in that solution, and you will get almost equal, even better finish than what available in the industry now. So that is, and after development, we have commercialized that one to a private company, and that is now available. Even it's available on Amazon now. So you can just, for your trial, you can purchase it, and you can just trial it and evaluate it. So this is for your domestic use. That was for this photograph shows domestic use. You have seen those kind of tarnished items that can be easily cleaned using your this product. Now second thing, so that was basically a water-based chemical, and that is used during the production line. Now sometimes happens that you cannot use water in some components like electrical components or some other specific components. It's not recommended to use water. So for that we have also devised a solvent-based anti-tarnish, which again contains, it's a basically silane-based product, and silane is one of the safest chemicals. So it's basically produces silica, which is sand. So it's almost edible, so there is no hard side effect on it. And this forms a very small nano coating on the surface of that one and prevents from tarnishing. So that was one use. Second was the anti-tarnishing lacquer. So the coating produced by those anti-tarnish reagents is in nanometer level. So they provide protection up to, if you keep it in outdoor, maybe 6 months to 1 year, or in the sealed environment, it will go for 10 years. But those decorative items which are kept outdoor, so you need a thicker coating. So for that we have developed a polymer-based coating. It's called lacquer. And what we have done actually, so we have synthesized and developed a new polymer. Existing, if you see the existing products available in the market, it's a mixture of polymer and some corrosion inhibitors. There they simply physically mix it and it produces the lacquer. So what we have done, we have integrated those corrosion inhibitors in the polymer chain itself, so that the stickiness, that bonding between the silver and the polymer becomes more, and it provides long-lasting corrosion protection. So we have Indian patent for that, and we have commercialized that one in the name of Silver Care also. This is in the liquid form that can be used by dipping by spraying or by using a brush. Any kind of application you can do it, and you don't have to do any baking. So majority of those lacquers, they recommend a baking. So in Indian scenario, this was first particularly developed for the Indian artisans, a lot of, particularly for artisans in Kotak, where that silver filigree is made. So they don't have those kind of setups to heat it, all these kind of things. So our objective was to make a system which is just simply use and air drying. So this is a air drying lacquer, and it can be used, and you can see the efficiency in that if you put it in sulfur, flower of sulfur test, that is ASTM B809, where we intentionally put the silver items in S2S atmosphere, sulfur atmosphere. So if you take a normal silver, it will within 5 minutes it will black, it will tarnish. It's very severe, and here you can see after 10 hours of dipping is also putting in that atmosphere, that coated item is nothing is happening. It is not getting tarnished. So it's a very efficient lacquer, and it's also available in the Amazon. So for your trial. Now after this one, there is another development. Actually, we have a facility called gas atomization for the production of silver powder. So we are taking up a need to produce silver powders for bulk consumption in solar cells, all those things. So we have a facility to produce silver powders in commercial scale, bulk scale. And we have already tried the system for production of gold powders as well as silver powders. And any industry, they can come to us and use the facility with giving the charge. Suppose you have a plan to produce, because this equipment is available, so you can always purchase if you want to for a commercial production. But before that, if you want to trial your results, whether it is how it is giving and how you can make a paste out of it, so you can produce those silver powders using our gas atomizer. So in addition to that, we can provide solutions to extraction of silver from secondary sources, and then development of new kind of silver alloys. If you want to, like, I don't know how much you may be aware, if a minor addition of aluminum in the silver alloy, minor means only 0.1%, it can greatly enhance the anti-tarnishing property of the silver alloys. So I don't know, very few people are using that one, but even some people, if somebody is willing to take the challenge and sponsor a project to develop a tarnish resistant alloy, so we can help in that also. And by addition of 0.1% of aluminum onto silver, it can help a lot in producing tarnishing resistant silvers. Then we also are working on green chemicals for surface finishing of silver and anti-tarnishing reagents. And also we have a very good facility for chemical testing. All kind of any kind of metal can be tested at Metallurgical laboratory. We have advanced facilities, and we provide, and our facilities NABL accredited. So we provide chemical solutions to all. So if you need any kind of chemical characterization, they can also approach NML. Thank you all.
Thank you, Professor. I think this is really interesting. We'll request Amol to share his.
Okay, good afternoon, everybody. I know that since morning all of you are attending so many presentations and we are in the last phase. I will make sure that we keep you entertained and we'll get to know something new that we are doing. Can you hear me? Okay, fine. So I'm going to talk about scalable manufacturing processes for silver nano as well as other metals. I'm going to focus on the second part also to some extent. Now, we all know that in the last meeting which happened in Jaipur, I had just introduced all of you to silver nanowires. We also had started. Now I'm going to cover specific things. Silver nanowires, now we have been able to do some new developments. I will show you that. Something different, silver on silica, then copper nanowires and copper nanoparticles and silver coated copper. And finally I will touch upon something which is a little different but a lot more interesting. Everybody knows that silver nanowires go in touch screens. They also go in many different applications where you need to have kind of reduced quantities of the silver going in the application, because using only flakes or the powders will keep on only adding the amount of silver that you are using for specific application. Wires being longer, what you need is a contact between 2 points, and that helps you to reduce the overall content of silver in any application. It is known that this application of silver nanowires are going to grow significantly as the flexible electronics will come into picture. Now that's already there. We all know that people use Fitbit, and now there are foldable phones are also around. Many people are using them. The touch screens are made of silver nanowires. In all such cases, the applications will keep on increasing, and so will be the demand, and the demand will grow to a significantly large amount as in another couple of years time. And there are different applications, mainly the current collector paste, then conducting electronics, RFIDs that we see typically still use a lot of silver in that, along with some aluminum, and finally the LED applications. If you look at the silver nanowires prices, I will just like to just yesterday I googled and just tried to find out what are the latest prices per gram. So if you look at the screen, you will see that basically it's anywhere from $200 to $500 per gram. Look at many different suppliers. Its prices talk about $300 per gram, 60,000 rupees per gram, anywhere from $200 to $280 per gram, and so on and so forth. Then this recently, one company says that they have cheaper, but then the wire diameters are very, very wider in terms of range. So, but the niche applications demand wires which have very high prices. And the reason why the prices are high is all because one cannot make them in really large quantities. We have been able to crack that problem. So we have been able to make silver nanowires in good quantities in the lab. We can make 500 grams every day in a continuous mode that allows us to make them consistently. The reaction times are anywhere from 10 minutes to 20 minutes. At slightly higher temperature, diameters are from 40 to 60 nanometers. We have tested them for different applications. And if you look at the prices, the cost of nanowire that we make per gram is almost close to $10 as compared to what is the $180 price that is available in the market. If you add the labor cost and all other costs, it will not cross $15 at all. So look at the overall margin. When we did this last time, the Silver Institute in their Silver News covered this particular item, and then they showed that we have been able to reduce the price significantly. We have some more advances now. We have been able to bring down that 10 to 20 minutes to less than 2 minutes time. So you will be able to make these wires on this podium here without any additional infrastructure. The global market, as I said earlier, it will increase as the use of solar cells will increase, displays will increase. Any and everything that you see around here, the demand is only going to grow, which clearly indicates that the market for silver nanowires is also going to grow. Another thing that we did last year was we were having a project where we were tasked to make silica in very uniform form, anywhere from 500 nanometers to 1.5 microns. That goes in the chromatographic applications in the pharma industry. But that application needs a highly porous silica which has to have a surface area of 1100 meters square per gram. And the price of that silica is almost close to 8,000 rupees per gram, which we import completely. While we were doing that, we also developed a process for making non-porous rigid silica and used that for impregnating silver on that. And what we could see that we were able to impregnate or deposit silver on this silica almost uniformly everywhere. What it allows you to do is that what you are able to do with silver alone, now you will be able to do it with only 10 to 20% of the silver that you need. So overall consumption of the silver in a given application will decrease significantly, because what you need is point by point contact, which is very much possible by such methods. So if you look at the outlook of the silver nanowires as such, the top manufacturers are all global players, big ones, right from Cambrios to Blue Nano, 3M, Saint-Gobain, and so on. And all of these uses for a variety of applications, including the touch screens. The demand is going to grow from 5 tons per year to 11 tons per year by 2025. The bottleneck is large scale production, and we believe that probably we have solved that problem. makes these copper nanowires and copper nanoparticles. We have been able to kind of make copper nanowires in good quantities and in a very kind of narrow particle size distribution. They can be used for, again, for making conducting paste. They can be coated with silver again for making kind of the very thin core shell nanoparticles where the core is copper, shell is silver. And again, the thickness of silver on the copper is very, very small. Then copper nanowires as well, because silver coated copper nanowires will give a significant boost in reducing the overall amount of silver that goes in current collector paste in the solar cells and any other kind of contact applications. You can see this beautiful copper color that comes when you kind of make these wires in good quantity and very, very high yield, almost 95%. We have been able to use these for making conducting inks for different applications, and if you see here at the bottom, I showed the NCL diary on which we have put one slide, a glass slide with coating of this ink, and we were able to lit the LED, and you can't see that the slide is completely transparent. So it means that basically the ink has no color. You can paste it, you can basically print it anywhere, you don't detect that there is a circuit, and you are still able to flow the current through that. Let me come to the last slide. One development that we did in last 1 year was on platinum on carbon as a catalyst for fuel cell. This may be a little offbeat from this particular forum, but I think that the way demand for silver as a catalyst will grow in the time to come, platinum on carbon is also going to come very big way. Typically, conventionally, the platinum on carbon is used in the chemical industry for carrying out hydrogenation reactions, but there the amount of platinum that goes on carbon is only 5 to 10%. When it comes to the application of fuel cell, which will go in the electric mobility and where the demands are going to be huge, what you need is a catalyst with 40% platinum on carbon. It's a significantly high loading of platinum on carbon. Right now, only 2 to 3 companies all over the world make this particular catalyst. So we have been able to make another very peculiar thing required here. Your platinum particle size has to be between 2 to 3 nanometer size. It cannot be more than that. It should be uniformly dispersed. So we have been able to come out with the method to make this particular catalyst in good quantities, and as compared to kind of the market price right now, if you see it's the fuel cell store that supplies the catalyst, or even the other companies like Johnson Matthey and Tanaka, the prices are really high because platinum cost itself and the loading that goes is also significantly high. We have been able to minimize it significantly. I feel that these are the areas where typically the Indian companies need to kind of rush and get into, because our population is increasing. We are always seen as the largest customer base for the entire world, majority of the large companies, and we kind of just can't be the formulators or the assembly manufacturers here. We should also start making the products based on our own technologies. These are all the students who did this work. Kind of primarily Jayesh did the silver nanowires, further improvement, reducing the reaction time from 20 minutes to 3 minutes now. And all other students also worked on these different projects. Thank you very much for your time.
Thank you, Dr. Amol. I think this has been a very informative session from the 3 distinguished speakers. Before I go to the question, I think there is one question. What I would like to convey is definitely I've been through this journey of innovation for the last 30 years, and what I've seen is, and I think you all may agree, earlier it was like from the research to the final industry practice, it used to take a lot of time. It's a long time. But what we see here today, we see it practically, and I could see if there is 2 startups using that technology and promoting them, I think it's a very good thing. And I think if Srivastava is here, what I would request is, there are so many things which has been done, and we have all seen from the 3 presentations. So if we can, like in your Boolean world, if we can publish, that would be really good if we can, because a lot of people don't know. We don't know what is happening in the institute. You may be publishing or you may be discussing with few of the industry, but I think a lot of, like I was discussing with Dr. Amol that he has made nanowires, and today in the presentation, the moment I mentioned, there was one of the industrialists who was quite interested as to can he work on the silver nanowires. So I have few questions. We'll start with Dr. Parag. For the silver in photovoltaic, what is the diameter of the grains or this thing which we use, powder, which is there? And as I heard during one of the seminars that earlier it was 3 times silver which has been used. So what is your expectation of what is the current silver which is being used in a photovoltaic, and with your innovation of silver on copper, where do we reach? Where we can reach of how much would be the silver usage to give the same quality in the photovoltaic?
Okay, see, regarding the particle size, it's 1 to 2 microns. So we don't need finer particles here, at least for the high temperature paste, and I think same for the low temperature paste also. Now about the reduction in the silver amount, as you said, it's not just a function of the paste, it's also a lot to do with the screen designs, like how you deliver it on the cell, right?
Sure.
Those width of the current collection fingers, the bus bars, so those designs are also continuously changing. The ability to print, can we print that fine, right? So typically what they do is they would make the line thinner because that reduces the shadowing losses, but you want to increase the aspect ratio because you don't want to compromise on the resistance that may go up if you just decrease the width. So it's a combination of paste improvements and also printing. So that is very important to know.
But will it reduce as we go along?
It has been, like what Chandresh said, it has been reducing, right?
Yeah, it
all
has been
along,
reduced,
right?
yeah.
And yes, there's a lot of interest which we see in conferences in industry on the coated powders also. So there again, I mean, I would think definitely if we, let's say if we stick to the designs and all that, considering that all other things are constant, you should easily get reduction at least 50%, you know, by weight at least.
Good,
As long as it works for, you know, that particular device. But I think in high temperature paste it is not yet, probably not yet commercialized. Low temperature paste, yes. Yeah.
Does the impurities in silver play a major role here? You need to, what kind of silver would be required before you convert it into powder and paste?
Yeah, so certainly impurities will play a role here, because see, one is talking about particularly in the high temperature paste, you know, if you have impurities which are going to diffuse into the cell, then you're going to kill the performance of the solar cell. So you can't really tolerate that kind of impurity. So we would want high purity, let's say. I mean, but only thing is, I'm not talking metals bases here, because we work with, these are all chemically produced powders, right?
Sure.
So it is assumed that your salt solutions bringing from there to maintain that purity,
sure.
right? Yeah.
So here, one last question on this is definitely now we are making paste for electronics, and since and this is an interest to me also, or our company also, and you know, we all are going into a circular economy. So now what we need is, now you're developing something for electronics, but what we need now also is how can we take it out from that electronics?
Yeah.
So that is another big challenge, because we have now entered into the low grade recovery from the electronic waste. And what we find that recovery of the gold and silver or copper is not a easy thing. So I would say, is any work being done on that line?
Yeah, I didn't cover it here. So we had a project from a solar PV company who is into module manufacturing, giving us a project on silver recovery. Of course, I can't comment on the economics of it yet, right?
Okay.
It was done at a lab scale, and we have at least 3 different faculty colleagues at IIT Bombay who are looking at pyrometallurgical and hydrometallurgical routes. So it's a very active area at IIT Bombay right now. And
even in the, I would say, even in the electronic waste area, or it's only
yes,
in the photo?
it is cutting across. If you put all faculty members together, it is cutting across, not just solar, I'm saying.
Okay.
People are looking into other things also, PCBs or whatever. So there's a lot of activity. If there is interest, then we can interact, you know. I can also connect up other colleagues.
Thank you. Thank you. So I'll go to Dr. Mohanty. Definitely, again, this is really enriching for I think in the industry, and I'm not sure how much you have reached to the industry, because anti-tarnish of silver is really very important, and lot of industry, and end of the day, even we do a lot of coins, and we do almost 20-30 tons of coins a year, and we have resorted to lacquering. We have tried number of anti-tarnish. So the anti-tarnish which you said, other than the lacquer, what's the lifetime? What's the life of the anti-tarnish?
Yeah, so that anti-tarnish basically gives a coating of 2 to 3 nanometer. It's very thin. It's based on its concept called self-assembled monolayer, and it gives tarnish protection if you keep it outdoor without any covering. At almost 1 year, it will give protection. It will not tarnish.
But if you're wearing it, how is it? And if you are having soap solution, like if you're wearing a jewelry?
So in that case, we can safely up to 6 months actually, because soap solution is, not soap, basically sweat. Sweat is that basically contains sodium chloride, and it's a very harmful thing to metals. Sodium chloride is a very harmful thing to metals, including silver. So definitely sweat, all these kind of things, definitely I can tell you 6 months is the safe time period. And that lacquer definitely has give much better lifetime, but lacquer is not suitable for jewelries. So that I can tell you. Lacquer is for the decorative items, which are for display, all these kind of things. So 6 months is the time of your anti-tarnish.
Yeah, jewelry definitely what I've seen and what we know is most of them are going ahead for the silver plating or to avoid any anti-tarnish this thing. And I'll also simultaneously go through the question, does this anti-tarnish reduce conductivity of the silver or silver alloy?
Yeah, so the conduct, as I told, the thickness of the coating is very low. So it doesn't reduce the conductivity up to noticeable extent. It's very negligible. So it can be safely used for the electrical contacts. So there is no issues on a reduction in conductivity. So are you looking at the marketing channels? Yeah, so definitely we have an industrial partner who is producing. So it's basically MSME startup. So definitely, and this development was maybe 1 year old actually. So we are yet to explore its, as you rightly point out. So this is the best platform to propagate the news that we have a product, and our industrial partners are encouraged to evaluate it. And even if they find some shortcoming, they can always come back and we are ready to improve on it. So it's only feedback which will betterment the product.
Okay, one last question on this is, but you also said that you have a gas atomization thing. Do you also recommend the machinery used in that, for if any industry would like to do this thing, or it's the ready thing which is available in the market?
No, actually gas atomization is a very complex process. You cannot straightforward buy equipment and do it, because it optimization of the conditions, running conditions is a very critical there to get the control, the shape, size, all these things. So that's why we have purchased this equipment through Government of India funding, and it's open to all. So it's not that we are closed, because we are taking up projects like I can tell you that Titan has utilized that one. So other companies can come also, and we have kept a very negligible price actually, negotiable price. And you can always come, evaluate it, do your melting, do your powder production, and take it and do your use. So that is open for collaboration.
And I think there's another question, if the anti-tarnish was to be used on electrical contacts, would you estimate the life to be, since no sweat could be in contact?
Yeah, that I was telling. So once it is used in the, actually it has two advantages I see in that way. Before selling, appearance is also a very good customer approval. Suppose there is in the shop itself, one is tarnished thing, another is fresh thing, definitely your market demand increase. So that is one positive point. And once it is goes inside the system, so suppose assemble all those things, so it gives a fair long protection. Anyway, the conductivity is going down actually because of the formation of oxide, silver oxide. If in contact, if you don't use any anti-tarnish, that also the conductivity will go down with time because of the formation of silver oxide. So definitely it will be better than that one.
Thank you, Doctor. And now I'll move to Dr. Amol. And I think really great to hear about your development of silver nanowires and what you told me yesterday. You have commercialized it to almost 1 kg production. I would like to know, I know it would involve rolling, melting, rolling and drawing. What's the capex? What's the total setup required if, say, you have to do, say, something like 50 kgs or 100 kgs a day or something like that?
Okay, so first and foremost thing, there is no melting, drawing, etc. involved.
Oh,
this starts with silver nitrate as the salt, and the reaction of silver nitrate or reduction of silver nitrate gives you silver. And what is required here is that if you do not have growth directing agents, then you will get only particles. But if you do not allow the particles to grow on all the sides but only in one direction, that is when you get the wires.
Oh, I see. Yeah. Okay.
So the typical capex required for if somebody wants to go for, say, 1 kg, I think it is a little too high quantity, because the wires required at this point of time, even for a specific application, would need not more than, or a vendor would not need more than 100 to 200 grams per day of the wires. And for that, the capex required as of the present process or any point of time, the total process, it will be somewhere close to around 25 to 30 lakh rupees only.
And what's silver on silica? What's the commercial? Where is it application in the industrial domain?
Okay. See, typically the amount of silver used in the your solar pastes and any kind of contacts where the demand is to reduce the amount of silver now, because it's becoming, as the prices are increasing. So what we do is that we basically coat silver on a silica particle, and when you make a paste out of that, your anyway surface contact is happening, and so the current will anyway flow. So the total amount of silver used in a given bulk is going to be only 10 to 20% as compared to what you use now. So performance will not get affected.
And I think we have a question, if I could read it. What is the continuous length you have produced nanowires, and how much is the hardness reached at the final stage, final size?
Okay, so this is, again, as I said before, it's not that we have drawn the wire, but the aspect ratios are more than 1000. So kind of for a given diameter, say for example, if I have 60 nanometers, then the diameter length will be somewhere close to around 6 microns or even beyond that, 60 microns and beyond that. You cannot draw a single nanowire of that kind, because that will not be stable at all. So this is made from the salts, and so not drawn from anywhere. But typically as the diameter increases, your transparency goes down, so applications change. So for every diameter, the application is different.
Thank you to all the three distinguished guests. Before I close, let's go, what would you see, because you have been here for the last today and yesterday also, what do you see, how would industry, what is your view currently seeing the whole silver scenario in a short this thing? And second, if you can also highlight what we see, there is a lot of work which is being done by each of the institutions. Is there a sharing which happens, or is it all individual developments done by research students?
I think so. Let me come first. So me and Professor Parag, we have been interacting, but on some other material, not on this particular one. I think I'm a chemical engineer, and we focus mainly on scale up of the materials, that whatever that people do at milligram scale, gram scale, we take it to larger scale, which is a challenge, specifically because you want to produce good quantity of material without affecting the particle size distribution or the wire size distribution, which is a good challenge to work on. That is where we focus on. So I think we have complementary competencies, and there is no competition as such. So it's a good synergy. Yes.
And what do you expect from the industry? What are you looking from the industry?
I think two things. One is that I see some of us are working on applications where or the products where we know that yes, definitely there is a demand and a proven market outside. Our industries probably need to take one or two steps in the forward direction. We'll be happy to discuss. There will be challenges obviously in technology transfer. There will be always challenges in terms of penetration in the entire value chain of that particular product and so on. But at some point of time, because we cannot be just assembling the things, we cannot be just purchasing the formulations. We have to create our own formulations. We have to also develop methods. Frankly speaking, some amount of investment in the R&D is absolutely essential, because not all things that we do in the lab scale may not reach the regulatory norms of what is commercially required. So that helping hand, because we are far away from that domain, so industries are very close. So I think this kind of a networking will help us. It will help them as well as it will help us a lot. That's what we feel.
Professor Mohanty, what's
just one
your
small
view?
thing. I
Yeah,
think
sure.
one of my students started a startup on making copper oxide nanoparticles because he felt like he's going to find use in the agrochemical industry. This is almost 4 years back. I think now he earns 5 to 6 lakh rupees as a net profit every week.
Oh, wow.
Yes, so I think students have a huge appetite for these kind of areas. So identifying and there are many startups in this domain. So I think the next time probably we can identify the startups in this domain and ask them to also come and there can be a session on that.
Yeah, I know, because I met the professor who has done on the conductive ink in ISC Bangalore, because I'm a pass out from ISC Bangalore, so I met him and he gave me a full brief on that. I think he was looking for some investors for the conductive ink. What's your...
Yeah, so regarding our expectation from the industries, so as he pointed out actually, so we do R&D with a scientific bent of mind, and we enjoy that process to develop something, and we try our best to meet the challenges. Now the actual user are the industries, they know better than us that what are the actual requirements. So if they come forward for to talk, so just if you find some knowledge that okay, something is done there, you just come forward and discuss it. That will help a lot to us. Even you may not take the technology, but somebody else will take. But your feedback will help us to further modify that one, and we'll be able to meet that challenges. And also, I can tell you, being our charges are a little bit high for MSME. If you that's we should highlight on that. But right now, with this government, so that has come down. Earlier, we had fixed that price. Okay, below that price we will not go. But this government is particularly encouraging MSMEs to come forward and take the technology. So we are in the process of negotiation of that also. Suppose one MSME comes and they are not able to afford that one, our price changes from MSME to a big company. So price-wise also we are a little bit more relaxed now. So you can come forward, just come forward and have a discussion. That will help both you as well as us. Thank you.
Professor Parag.
Yeah, so regarding sort of expectations from the industry, I think every time that I'm in forums like these, it's very exciting when you get to hear of a problem statement. And I've been telling my students, sharing with colleagues, that everything begins with a problem statement. Otherwise, what can happen is we decide what the world needs and it will never go anywhere. You know, it just doesn't go anywhere. I can decide by reading research literature and then finally end up in theses. So problem statements is very important. I do understand that they can't be just generally shared, but then it has broader, you know, these things that, you know, we should build relationships, and it has been said on many, many forums, and this is one interesting forum. The second thing I feel is that when you look at, I think there were some presentations which mention the percent either on, again, I may be confused, I'm not a business person that way, that percent either on revenues or profits, but I would like to ask how many companies are willing to put aside X% of their revenues for R&D?
I think that's a big
because
question.
if you only remain in the ROI kind of game, then we're sort of, this is sort of going in circles, right? So I feel that if companies start to put some % of their money for R&D, which need, and secondly, which we always hear. I also like Dr. Amol and all of us, we interact with industry a lot. But many times you also see or you hear that the expectation is that you should deliver something which will give me revenues tomorrow. If that's going to happen, then we will never come up. It does take some patience and walking along. And while you walk along, I think it will happen. It will start happening that you will shorten the times when you will make revenues on these things. But I think putting aside some money for R&D, which may not necessarily give you immediate returns, and then walking along with some patience will possibly help all of us, and in the end, of course, the companies,
So thank you very much. I can hand over the mic to.
Thank you so much, sir. And I must say, not only this has been interesting, spoken like a true diplomat, Dr. Kulkarni, when you spoke about collaborating with your co-peers and other scientists. And yes, while the common issues of the industry and research have already been discussed here, it's time for us to now change the format a little, prior to which I would once like to thank all the panelists up here, and I would like to invite our chairperson, Mr. Ankur Goyal, to please present a memento to all the esteemed scientists on this stage, starting with Professor Parag Bhargava. Thank you to Dr. Ashok Kumar Mohanty, sir. And a big thank you to Dr. Amol Kulkarni. Do we have Mr. Dhruv Narang in the house? Sir, may I invite you on the stage to please present a memento to our chairperson. Gentlemen, please stay on the stage. I would request you all for a group picture. So ladies and gentlemen, in the meanwhile, from the research end, you've already heard there's a certain amount of push and pull from the industry side as far as the gestation period of new technologies is concerned. And while on the surface we've already talked about common issues, it is time for us to jumble this up a little. Now this is a closed door meeting for the next half an hour. Anyone who wishes to be a part of it is most welcome. We would not be recording this. This is your chance to get into a one-on-one conversation with the science leaders of the industry. So gentlemen, let me tell you what we are going to do. Just like, आप में से कितने लोगों ने speed dating के बारे में सुना है या वो format देखा है? Can I see hands up? सब लोग dating से तो काफी आगे वाले लग रहे हैं मुझे यहाँ. Okay, so we are basically going to be assigning a round table to each one of our specialists here, since their core competencies are different. The product lines that they are working on, the technologies that they are working on are different. We are going to be assigning them separate tables. And each one of you is most welcome to address each one of them one by one with your personal industry specific concern, or if there is a particular material or a particular issue that you're facing, and I'm sure they would be able to help you out, or maybe they would be able to give you some projection as to how this issue can be resolved. So as we assign tables to them, this is a closed door meeting, no recordings, a one-on-one private conversation. Feel free to take their time. Can we start assigning them tables, please? So Professor Parag Bhargava takes the first one. I would like to request Dr. Kulkarni to take another end of the hall. And similarly, I would request Dr. Mohanty to take yet another end of the hall. Sir, थोड़ा सा और 2-3 टेबल छोड़ सकते हैं आप, ताकि लोग खुल के बात कर सकें आपसे. So ladies and gentlemen, feel free to rotate amongst these specialists and bring forth your concerns. Let me tell you, we will keep this session open for a while. This is the conclusion of the India Silver Conference 2024. 7:30 onwards, the gala cocktail dinner begins at Seaside Lawns, following which we will have an after party in the Mobor Hall. Just to let you know, Mobor Hall is the banquet hall across the swimming pool of the hotel. So that will be all set for your after party later with the DJ in the house. But right now, let's discuss science a little bit more and let's do some networking. And this is also to let you know the stage is open for a while. So just in case any of you wants to come and click some pictures, if you're a contingent of a corporate, if you're a particular group of people who've come together, please make sure that you use the stage to click your pictures. Please use our hashtag ISC 2024, hashtag ISC India Silver Conference. Let's spread the word to the entire silver industry.